Hello students! Welcome back to MathTalinoClassroom for another problem-solving tutorial. In this video, we will be discussing about uniform motion problems. We will start with reviewing the general concepts that we might be using in solving such problems. Recall that distance is equal to the rate or speed times time, or in symbol that is d is equal to r times t. We also consider two different cases that we might encounter in solving uniform motion problems. The first one is when two bodies are traveling in opposite directions. Like for instance, if we have two objects, and when object number 1 travels towards the direction of object number 2 with a distance traveled denoted by d sub 1, and when object number 2 travels towards the direction of object number 1, and the distance traveled is denoted by d sub 2, and at a certain time they meet at a given place. So the total distance traveled by the two objects when they meet is denoted by d sub total. Another scenario is when object number 1 travels at a certain direction denoted by the distance traveled d sub 1, and at the same starting point we also have object number 2, but this time it travels in the opposite direction with the distance traveled denoted by d sub 2. Notice that at a certain period of time their total distance traveled can be denoted by d sub total. In two scenarios, if we combine the distance traveled by object number 1 and the distance traveled by object number 2, that is equal to the distance total. Hence, our formula for case 1 would be d sub 1 plus d sub 2 is equal to d sub total. Another case that we might consider is when two bodies are traveling in the same direction. A sample scenario for this one is when object number 1 travels towards a certain direction and having the distance traveled denoted by d sub 1. And after a certain period of time, we have object number 2 starting at the same point, would like to catch up with object number 1. So it travels in the same direction until it catches up with object number 1, and the distance traveled by object number 2 is denoted by d sub 2. So at the time that object number 2 already overtook object number 1, it means that the distance traveled by object number 2 is now equal to the distance traveled by object number 1. So our formula for case 2 would be d sub 1 is equal to d sub 2. Let us remember these two equations, and we will try to apply one of these equations correctly in our problems. Let's start with problem number 1. Two trains leave a train station at the same time. One train travels west at 45 kilometers per hour. The other train travels east at 50 kilometers per hour. In how many hours will the two trains be 142.5 kilometers apart? We start our solution by creating a table to summarize the given data. We create a 4-column table. The first column would be allotted for the two objects involved in the problem. The second column would be the rate for the speed. The third column would be allotted for the time, and the last column would be allotted for the distance traveled. For train number 1, it is stated in the problem that it travels 45 kilometers per hour. And for train number 2, it travels 50 kilometers per hour. For the third column, which is for the time, we know that time is missing in our problem because that is what we are asked to solve in the problem. We just denote the time traveled by train number 1 and train number 2 as x. For the distance, going back to our general formula, we can compute distance by multiplying rate and time. So we have 45 times x. So the distance traveled by train 1 is 45x. For train 2, 50 times x, that would be 50x. After completing our table, we can now create our equation. Going back in our problem, notice that the two trains are traveling in opposite directions. One is traveling towards west, and the other one is traveling towards east. So it means that we need to use the equation number 1 that we have presented earlier. We have distance 1 plus distance 2 is equal to the distance total. So distance 1 for train 1, we have 45x. We add that to the distance 2 for train 2, which is 50x. And the total distance, according to the problem, is 142.5 kilometers. So our equation would be 45x plus 50x is equal to 142.5. Now, we solve for the value of x in this equation. We combine similar terms. 45x plus 50x, that is equal to 95x, equals 142.5. And finally, to solve for the value of x, we simply divide both sides of our equation by 95. So we cancel out the 95s on the left side. And what will be our result is x equals 1.5. Going back in our table, we know that x represents the time that the two trains will be 142.5 kilometers apart. It means that after 1.5 hours, train 1 and train 2 will be 142.5 kilometers apart. So we state now our final answer to this problem. Thus, the two trains will be 142.5 kilometers apart after 1.5 hours, or 1 hour and 30 minutes. Let's proceed to our second problem. Two buses are leaving at the same time from two different provinces that are 200 kilometers apart. If bus A travels 5 kilometers faster than bus B, find their speeds if they meet after 2 hours. We start again with creating a table to summarize the given data in our problem. Let's focus ourselves to the second column, which is the speed for bus A and bus B. According to the problem, bus A travels 5 kilometers faster than bus B. It means to say that if bus B travels x kilometers per hour, then bus B travels x plus 5 kilometers per hour. Next, for the third column, which is the time, according to the problem, they meet after 2 hours. So the time traveled by bus A and bus B would be 2. And for the distance traveled, we simply multiply the rate and the time in our second and third column. So for bus B, x times 2, that is 2x. And for bus A, x plus 5 times 2, so that would be written as 2 times the quantity x plus 5. And now we create our equation. Take note that in our problem, the two buses are traveling in opposite directions since they came from different provinces and they traveled and meet after 2 hours. So the equation that we will be using would be d sub 1 plus d sub 2 is equal to d sub total. For d sub 1, which is the distance traveled by bus A, we have 2 times x plus 5. Then we add that to the distance traveled by bus B, which is 2x. And the distance total traveled by the two buses is 210 kilometers apart. So, in equation form, that would be 2 times quantity x plus 5 plus 2x equals 210. Solving for x in this equation, first, we distribute 2 to x plus 5. So that becomes 2x plus 10 plus 2x equals 210. Combining similar terms, 2x plus 2x, that would be 4x. Then we just copy positive 10 equals 210. Next, we transpose positive 10 to the right side. So the equation would now become 4x equals 210 minus 10. Simplifying, 210 minus 10, that would be 200. And finally, to solve for the value of x, we simply divide both sides of our equation by 4. So we now cancel out, and 200 divided by 4, that would be 50. So x is equal to 50. Going back in our table, the variable x represents the speed or rate of bus B. So meaning to say, bus B is traveling 50 kilometers per hour. And for bus A, since it travels 5 kilometers per hour faster than bus B, so we simply add 5 to 50, so that becomes 55. So bus A is traveling 55 kilometers per hour. Now we state the final answer to this problem. Thus, bus A travels 55 kilometers per hour and bus B travels 50 kilometers per hour. Let's now proceed to problem number 3. A jeepney leaves Ronnie's house at 60 kilometers per hour. 2 hours later, a taxi leaves the same place at 80 kilometers per hour. How long will it take the taxi to overtake the jeepney? So let's organize the given data in our problem using a table. For the jeepney, its speed is 60 kilometers per hour, while the taxi, its speed is 80 kilometers per hour. Take note that the jeepney already traveled 2 hours after the taxi started following the jeepney. This means that the jeepney has traveled an extra time of 2 hours. So, the time traveled by the taxi can be represented by variable x, and the time spent by the jeepney in traveling would be denoted as x plus 2. And for the distance column, we simply multiply the rate and the time in the second and the third column. So for the taxi, we have 80 times x, which is 80x. And for the jeepney, we have 60 times the quantity x plus 2. We now create our equation. Going back in our problem, take note that the jeepney and the taxi travels at the same direction because the taxi is trying to catch up with the jeepney. It means that the equation that we will be using would be d sub 1 equals d sub 2. So our equation would be the distance 1, which is for the jeepney, we have 60 times the quantity x plus 2. That would be equal to the distance 2, which is for the taxi, and that is denoted by 80x. Now, we solve for the value of x in this equation. First, we distribute the 60 to x plus 2. So that becomes 60x plus 120, which is equal to 80x. Now, we transfer 120 to the right side, and of course, 80x to the left side. So our equation would become 60x minus 80x, that is equal to negative 120. Simplifying, 60x minus 80x, that would be negative 20x, which is equal to negative 120. And finally, to solve for the value of x, we simply divide both sides of our equation by negative 20. So canceling negative 20s on the left side. So that gives us x equals negative 120 all over negative 20, which is equal to 6. So x is equal to 6. Take note that the variable x represents the time spent traveling by the taxi. So that means the taxi has traveled 6 hours. It means also that the taxi has already taken over the jeepney after 6 hours. Or the taxi overtook jeepney after 6 hours. Thus, the taxi will take 6 hours to overtake the jeepney. Let's have our last problem. Richie drove his car from home to the city at a rate of 20 kilometers per hour. After 2 hours, his brother followed him driving his car at 30 kilometers per hour. How many hours did it take his brother to overtake Richie? Again, we organize the given data using a table. For Richie, he drove 20 kilometers per hour. And his brother drove 30 kilometers per hour. Since in our problem, it asks for the number of hours when the brother of Richie will overtake him, we let x as the time traveled by his brother. And of course, since Richie already traveled in advance by 2 hours, his time would be represented by x plus 2. To get the distance traveled by Richie and his brother, we simply multiply the rate and the time found in the second and third column. Now, for the distance traveled by Richie's brother, 30 times x, that would be 30x. And for Richie, we have 20 times x plus 2. So we have 20 times the quantity x plus 2. Creating our equation, take note that in our problem, Richie and his brother was traveling towards the same direction because Richie's brother is trying to overtake Richie after a certain period of time. With that, the correct equation that we will be using in this problem is d sub 1 equals d sub 2. For d sub 1, which is the distance traveled by Richie, we have 20 times the quantity x plus 2. That would be equal to d sub 2, which is the distance traveled by Richie's brother, and that is 30x. Now, we solve for the value of x in this equation. First, we distribute 20 to the quantity x plus 2. So that becomes 20x plus 40 equals 30x. Transposing positive 40 to the right side and 30x to the left side, our new equation would be 20x minus 30x equals negative 40. Combining similar terms, 20x minus 30x, that would be negative 10x. That is equal to negative 40. And finally, solving for the value of x, we divide negative 10 to both sides of our equation so that we can cancel out negative 10s on the left side. That leaves us negative 40 all over negative 10 on the right side. So x is equal to positive 4. Going back in our table, the variable x represents the time spent by Richie's brother. So x is equal to 4, which means that after 4 hours, his brother already overtook Richie. Thus, Richie's brother will overtake him after 4 hours. And that ends for our problem-solving tutorial. I hope that you have learned something from this video. Thank you for listening.